Hi, and welcome to the supplementary materials for the aerial robotics course of the robotics specialization. This series of videos will introduce you to topics in mathematics, dynamics, and controls that we'll use throughout this course. First, I want to briefly introduce myself. My name is Sarah Tang, and I'm a PhD student at the University of Pennsylvania. My research interests are in developing motion planning algorithms that will allow autonomous robots to perform tasks in cluttered environments. Specifically, I'm interested in three types of problems. First, I'm interested in developing algorithms for a specific class of systems called hybrid dynamical systems. These are systems that have multiple modes of operation, each with their own sets of dynamics, and discrete events trigger transitions between these different modes. The challenge in planning for these systems is in planning not only the behavior of a system within a specific mode, but also in planning when and how the system will transition. An example of this type of system is a quadrotor with a cable-suspended payload. In this case, pickups and releases of the payload are the discrete events that trigger transitions between the with and without payload modes. In our lab, we've equipped a quadrotor with an electromagnet, allowing it to pick up magnetic payloads. And our algorithm is able to generate trajectories that pick up objects and release them to drop at desired locations. Second, I'm interested in planning for higher order under-actuated systems. These systems have many degrees of freedom, but cannot directly control all these degrees of freedom to arbitrary configurations. Again, a quadrotor with a cable-suspended payload is an example of this type of system. Both the quadrotor and the payload can rotate and translate in 3D space. However, they cannot do this independently. In fact, the trajectory of the payload determines a required configuration for the quadrotor. Our goal is to plan aggressive motions for this system. For example, suppose the quadrotor comes across a window obstacle where the height of the window is smaller than the length of the cable. Our algorithm can generate a trajectory that contains the necessary swing to bring both the quadrotor and the payload through this narrow gap. Finally, I'm interested in the multi-robot planning problem. In this problem, we are given a team of robots at set start positions. These robots must navigate to a set of goal locations. However, the goal that each robot must navigate to is specified beforehand and cannot be changed. The goal of this problem is to generate trajectories that will bring each robot to its goal while avoiding collisions with each other. Throughout this course, I will be delivering supplementary videos. These videos will serve three purposes. First, we hope to provide you with some technical background on concepts used throughout the course. Second, we'll work through some example problems that will help you with the quizzes and the exercises. And finally, there will be MATLAB demonstrations that will help you as you work through your programming assignments. I'm glad to see that you're taking this course, and I look forward to working with you.